Hello everyone, I welcome all of you once again to this series of ratio proportion, and we are in lecture number 2. In lecture number 1 we have discussed the basics of ratio and different methods to solve the ratio questions, okay, where we have discussed portion method, assuming variable and chain rule. In today's video we will look at the scaling property of ratio. Alright, so let's get started. So here is our question number 1, which says 3a equal to 6b equal to 9c, and then we need to find the value of a, b and c. Okay, so what do we do in this case? Now, usually what people think that if it is 3a, 6b and 9c, they take the ratio of a, b, c as these numbers 3, 6, 9, and that's where they go wrong. Okay, that's not the ratio. Just think about it, just think about it, that if you multiply a number by 3 and that becomes equal to another number multiplied by 6. So in this case, just compare a and b and tell me which one should be greater, a or b? Which one should be greater, a or b? Yes, definitely a should be greater. Why it should be greater? Because a you are multiplying with a smaller number and that is becoming equal to b multiplying by a bigger number, right? Let's take an example. If I say, let's say a equal to 4, that gives you 12. So 6 into b will be equal to 2, right? So this is what I am trying to say. A you are multiplying with a smaller number, yeah, and b you are multiplying with a bigger number. So that makes a greater number and b as a smaller number. I hope that's clear to you. So keeping this in mind, I'm sure you will discard the outcome, or you discard this opinion that if it is 3a 6b, if it is 3a equal to 6b equal to 9c, right? So it is 3 is to b, 3 is to 6 is to 9. Of course not, because this makes 3 smallest, a which is 3 smallest, and as we discussed just now, a has to be a largest number because a is multiplying with a smallest number to make it equal to the others. Yeah, I hope this is clear. With this example you can understand. Here if I say a equal to 4, which gives you 12, I need to take b equal to 2 to have 12 again. Okay. So yes, this is wrong. So how do you do it? How do you do that? How do you get the ratio in this case? So it's pretty simple. You assume all of them equal to another constant. Okay, another constant or another, yes, another alphabet. Let's say that's equal to k. Yeah, all three of them, let's assume that that's equal to k. If that is equal to k, in this case a will get you k upon 3, b will get you k upon 6, and c will get you k upon 9. Yeah, if 3a equal to k, so 3 will go down. Yes, I hope that this is clear to you. This is clear to you. Let me write one more step so that become clearer. So if I say 3a equal to k, I can say a equal to k by 3 with this relation. Same for b. If I say 6b, here 6b equal to k, so I can say b equal to k upon 6, right? And same goes for c also, which is 9c equal to k, so I will say c equal to k upon 9. So I hope this step is clear. Yeah, so we assume all of them equal to k, and then we have equated one by one. 3a equal to k, 6b equal to k, 9c equal to k, and then you get this way, these numbers: a equal to k by 3, b equal to k by 9, sorry, b equal to k by 6, and C equal to K by 9, right? Now, question said find the ratio. Now substitute the values there. Substitute the values there. Substitute the values there. A is to B is to C. A is K by 3, B is K by 6, C is K by 9. Alright. Now, you know, if the numbers are in ratio, if you want to simplify them, we can either multiply or divide to make them easier to look, right? Simple to look. So, K is common in all. Can I divide all of them by K? Yes, I can divide all of them by K. That will get you what? 1 upon 3, 1 upon 6 and 1 upon 9. Okay, I am going with all steps. I am writing all steps and I am going step by step for you to understand the foundation. Okay, once we are comfortable with all this step by step process, then we will skip some steps and come to the answer directly and we'll call it shortcut. Okay, so just be with me. Okay, now you got the numbers in fractions. You remember the first lecture where we have discussed if the numbers are in fractions, then what do? We multiply by some common number. We multiply by some common number so that 3 can cancel that number, 6 can cancel that number and 9 also can cancel that number. Okay, basically LCM of denominator. LCM of denominator. Yeah, we multiply by what? We multiply by LCM of denominator. LCM of denominators. What are the denominators? 3, 6, 9. LCM of 3, 6, 9. What will be LCM of 3, 6, 9? Tell me. That is 36, right? 36 is common between them. Good. Yeah, you guys are becoming intelligent day by day. Very good. Okay, so if I multiply by 36, what will we get? Multiply by 36. 36 by 3, 36 by 6 and 36 by 9. Okay, believe me guys, if you have faith on me, little bit faith on me, I hope I'm able to develop the faith as of now. Yeah, I'm able to develop the faith so far. So if you believe me and go to all the videos which I'm making, all the lectures which I'm making, you will be able to understand these chapters well and you'll be able to apply shortcuts also in the questions. Yeah, so I have prepared certain questions for you for the next lecture. You can see that in lecture number 3 we are going to discuss questions here. That's where I will use the methods of video 1, yeah, the chain rule and the portion method, the assuming variable method, and will solve a lot of questions. Okay, so now 36 multiplied in all. Yeah, that's how the ratio works. You have to, if you're multiplying by one number, you have to multiply in all the ratios with the same number. Yeah, all these values with the same number. So 36 by 3, 36 by 6, 36 by 9. Simplify that. 12, 6, 4. So what do you get the ratio? Oh, you can further cancel by 2. All right. Okay. Well, okay. Fine. I got it. The LCM is 18, not 36. Yeah, LCM is 18, not 36. So if we write the LCM 18, here we multiply by 18. You know how to calculate the LCM? I hope you are aware about it. 3, 6, 9 and then we divide by some numbers, right? Like if I divide, all of them are divisible by 3. So if I divide by 3, 3 ones are 3, 3 twos are 6, 3 threes are 9. And then again divide by 3. So 1 is already 1. So you don't have to touch this. This is not divisible by 3. So write as it is. 3 ones are 3. Then divide by 2. So already 1. This is 1. This is 1. Yeah. I hope all of you remember this method, yeah, to find the LCM. Then we multiply 3 into 3 into 2. We multiply what? 3 into 3 into 2. That gives you LCM as 18. So 36 was also not wrong. Okay, you can multiply with 36 and then you can simplify further. You will get the same answer. Don't worry. Don't worry. Yeah, but as I said, divide by LCM. So I should show you by dividing by LCM. Multiply by LCM. Multiply by LCM. Right? So LCM is 18. Multiply by that. 18 by 3. 18 by 6. 18 by 9. Yes. So 3 6 are 18, 6 3s are 18, 9 2s are 18. So the ratio you get is what? 6 is to 3 is to 2. That's your ratio of A is to B is to C. And you can see here, the A's portion is greatest. A's portion is largest. Yeah, A's portion is 6. Where B's portion is 3 and C's portion is 2. Yeah. So this is what I was trying to explain you earlier, that if it is 3A, 6B, 9C, A is multiplied with the smallest number. That means A should represent the largest number, largest value. A's value should be the largest amongst A, B, C. I hope that's clear to you. Yes? Very good. Okay. And then I hope you understood when we can assume that to be equal to K, and then we found this and then we got the ratio. Okay, what is the learning from this question? Learning from this question is, if you assume that to be K and then if you put all these values in ratio again, which is K by 3, K by 6 and K by 9, K is going to be cancelled. And this is going to happen every time whenever you have such question, right? And then what you get? When you had 3A, so for A you get 1 upon 3. When you have 6B, so for B you get 1 upon 6. When you have 9C, then for C you get 1 upon 9. So let us skip these steps and jump to this step directly in the next question. And then just multiply by LCM, simplify and get the answer. Let's try this, and then we will proudly say that, okay, we have learned one shortcut for this. Yeah, so let's see how does it look like. If you want to repeat that question number 1, go through that, because in this question we will skip certain steps. So as I said, if it is 5A, 12B, 13C, so I can say the ratio of A, B and C directly. I'm skipping some steps. Which are the steps I'm skipping? Assuming them equal to K, and then substitute them, divide by K. So I'm skipping this step and directly jumping onto this 1 upon 3, 1 upon 6. So how do you do that? So when you have 5A, so for A you are going to write 1 upon 5. When you have 12B, then for B you are going to write 1 upon 12. When you have that is equal to 13C, so we are going to write 1 upon 13. Okay, you also have to understand which method has to be applied in which situation. Okay, yes, great. You guys are intelligent, you guys are awesome. Okay, now if I want to simplify this, what do? We multiply by the LCM. Now you can see 5, 12, 13, there is no relation between them. Literally no relation between them. So LCM will be multiplication of 5, 12 and 13 directly, right? So let me not multiply and have value and then multiply here. Let me simply say that, all right, if I want to simplify this further, I will multiply this entire expression. Look at this. I am going to multiply this entire expression by the LCM. Yes, what will be the LCM in this case? 5 into 12 into 13. Yeah. Why am I taking 5 into 12 into 13? Because all three of them are prime number. Understand? LCM 3, 6, 9. There is something common between them, right? So it is fun to do by this method. It's fun to find out the LCM by this factorization method. but here it's all prime number. There is no relation between them. 5, 12, 13, no relation. I'm sorry, not a prime number, because 12 is not a prime number. 12 is not the prime number. But 5, 12, 13, there is no relation between them, right? So I can take the LCM, the least common multiple, as 5 into 12 into 13 itself. I hope that's clear to you. Okay. And this is what we call being comfortable with numbers. Okay. And I will keep on showing you such kind of important tips as and when we come across. So multiply. If I multiply here, what will I get? I'll get 5 into 12 into 13 by 5. Ratio 5 into 12 into 13 by 12 is to 5 into 12 into 13 by 13. What is the objective? Objective is have a number by which we can cancel the denominator and we get 1 in the denominator. That's the objective. Okay, that's the objective. Taking LCM is not the objective. Objective is to multiply with a number so that it can be cancelled with the denominator. Okay, 12 is cancelled, 13 is cancelled. So I hope you're understanding why are we doing it. If not, please ask in comments. Please ask in the comment box, or I'll try to leave my WhatsApp number here. You can use the WhatsApp number to ask questions. Okay, so we got the number here as 12 into 13 is to 5 into 13 is to 5 into 12. What do we get here? 13 is 12 into 13 will be 144 plus 13, 157, right? 157. Sorry, 156. (144) plus 12, right? 156, correct. Is 2. This is 65. This is 60. That's the ratio of A, B, and C. All right. So I hope you will be able to handle such questions henceforth. If you have 5A plus 12B plus, if you have 5A equal to 12B equal to 13C, and if you need to find out the ratio, I mean to say, if you have a number multiplied by a variable equal to number multiplied with another variable equal to number multiplied with another variable, and you need to find out the ratio of those variables, right? So I hope you will be able to handle these questions now. Okay. You want to try one more? Well, I have one more question for you. Now I want you to pause this video and then try attempting this question by yourself. Okay, and then let's see. Tell me whether my answer is correct or not. Okay. Great. So half of A, this says half of A equal to 2/5 of B equal to 1/3 of C. That's what you have, and you need to find out A, B, C. So do you remember, if we try to get the ratio, what do we do? What do we get? How do we do? We have the number here, like this number 1/2 multiplied by A. So we take this 1/2 as 1 upon. Let me give you the reference of the previous question. If I have 5A, I make it 1 upon 5. If I have 12B, the B's portion I'll make it 1 upon 12. 1 upon. Now from where do I get this 1 upon? Go through the question number 1. Yeah. So that's why I said it's very important to watch these lectures without skipping it. Okay. So the number here is 1/2. No problem. I'll make it 1 upon 1/2. B is multiplied by 2/5. Well, no issues. 2 by 5. And C I'll make equal to 1 upon 3 equal to A, not equal to, that is ratio. Yes. All right. I'm writing. I'll correct my mistake. Okay. Now 1 upon 1 by 2. If I simplify this part, I'll make it what? Denominator will go into the numerator. Denominator will go into the numerator. Remember? Yeah, this will get inverted. So 2. So 1 by 2 become 2 by 1 here. This 2. 2 by 5 will become what? 5 by 2. This 2. 1 upon 3 will become what? 3 upon 1. And upon 1 we'll never write. So we never write upon 1. That's fine. So we'll write as 2. We write as only 3. Okay. Now I have got denominator here 2. So I need to simplify this. How will I simplify? Just multiply, not divide. Multiply by 2. Multiply by 2 in each term. Of course, in each term, because in ratio, if you multiply by a number, you need to multiply in each term. Same number multiply in each term. If you divide, then divide by the same number to the each term, right? Okay. I hope you're learning ratios well. Go on. Multiply by 2. So you got 4 here. 5 by 2 into 2 is 5. 3 into 2 will be 6. This is what you have as A, B, C. Is my answer matching with your answer? Yes, I'm sure it is matching. Great. Good. Thank you to validate my answer. And see, these questions I'm right, and these lectures I'm taking, these are the basic lectures. Okay, when I'm going to solve the LOD 2, level of difficulty 2, level of difficulty 3, I will mention you. I will have that in coming lectures. Okay, so if you are already comfortable with ratios, you can skip this lecture and go to the next one. The only loss you will have is we will not be using the same terms. Yeah. Like I use portion method. There is no method in the book called portion method. I call it portion method just to identify, just to remember, just to give the reference. Yeah, just name it. Okay, fine. So you got UV is okay. That's next question. So this is now okay. New type of question we got. So it's not anymore 5A 12B. No. Ratio now. U is to V equal to 6 is to 7. V is to W equal to 21 is to 6. We need to find out U, V and W. Alright, let's do it. So a scaling property, with using scaling property, there is nothing called scaling property also. Again, we are naming it just to take the reference, just to give the reference in future. So I'll tell you, okay, in this question I'm using scaling property. So you should be able to recollect that. Now, this is a question where you got U is to V equal to 6 is to 7 and V is to W equal to 21 is to. Now, tell me one thing. V is one variable, okay, V is one alphabet, let's say one alphabet which is given in this question, and then we got two conditions with V. In equation number 1, let me call it equation number 1. Here also I have got V, which is representing the value 7. And in equation number 2 also I have got V, where V is representing the value 21. Okay. When V is part of the same question, it should represent the same value, don't you think so? Why is it having different values in both equations? Because representing different values in both equations, because ratio also mean if and then comparison. So compare to u, when you compare to u, v represent 7. When you compare to w, v represent 21. So this is okay. It's not print mistake here. All right. Okay. But we also have to keep in mind v. It's of same question, so it should show same value. If it is not showing the same value, no problem. We will make it same. How will we make it same? How will you make it same? Tell me one thing. Tell me one thing. Here v is 7 and here v is 21. To make them equal, make this these values equal. Can I multiply this 7 by 3? It will become 21. Yes? Very good. Because we are learning ratio, in ratio, what is the property of ratio? If you multiply one term with one number, you have to multiply all the terms of that ratio with the same number. It means if I am multiplying this 7 by 3, I also have to multiply the next term with the same number, 3. That's the property of ratio. If you divide by the common number. If you multiply by the common number, right? Are you okay with this? Yeah? Let me repeat. If you find same variables at one side, but at the other side they are the same variable representing different values, different numbers, it's your duty to make them equal. How will you make them equal? Do some multiplication, division, but make them equal. Okay. So 21, here I have 21 and here I have 7. What will I do? I know 7 3s are 21, which will make it equal. If I multiply by 3, I need to multiply this entire ratio value, which was what? 6 and 7 by 3. So if I multiply by 3, I need to multiply by 3 in both these terms. Yes? Yeah, this is ratio. Multiply by same number, divide by same number. Property of ratio. Yeah. So that's how we can make them equal. We cannot add or subtract, but we can multiply or divide. When you multiply by the same number, this will not affect the relationship of these variables. So it will not change the ratio. All right. So now if I combining this and if I want to write u, v and w, now pay attention to the words. With equation number 1, I can say if u is 3 6 are 18, then v equal to what? 7 3s are 21. Right? Now second equation. If v equal to 21, then w equal to how much? 6. So you got the ratio of u, v and w. Okay. Let's do it again. Let's do this again. I have more questions of the scaling property, but let's do this again. Let me show this again to you. Writing all the same values here. So I have u and v, which is equal to 6 to 7. And then we got v is to w as 21 is to 6. Now scaling property means what? You scale up, you increase, you scale up. Okay, but by scaling up you should make the values, the same variable representing equal, same values, same variables representing same values. Okay, so here I have v, which is common. V here is representing 7, and in the second equation it is representing what? 21. How can I make them equal? I can make them equal by multiplying by 3 here. So 7 3s are 21. But can I only multiply 3 into the second part or second term? No. That's not how a ratio works. Ratio, property of ratio is what? If you multiplying one term by one number, you need to multiply all the terms by the same number. Now here all the terms, what? You have another one, you have one more term, that's it. Yeah. So this is what you get, and then just write then simply write the ratios, which says if u equal to 18, then v equal to 21. If v equal to 21, which is already there, then w equal to 6. That's why we multiply to make them equal, right? So that I can also relate u and w, which we were not able to relate earlier, because the same variables were not showing the same numbers, same quantities, same values. I hope that's clear. Okay, so when you make v represent same number, then you just write that number, and accordingly whatever changes has happened with u, we write the changed value here. I hope that's clear. Let me solve one more question for you. Let's see if you had any doubt earlier. Am I able to simplify your doubt here or not? Now here I got AB, BC and CD. Okay, so there are 3 questions and you totally got 4 variables, A, B, C, D. And you need to find out the value of A, C, D. You need to compare A with C and then D. Okay, no problem. But can I compare A with C directly? Here I have A compared with B and then B compared with C. Ratio means what? Comparison. Remember, ratio means what? Comparison. We have discussed this in the lecture number 1. Okay, so I hope you don't mind if I give the reference of lecture number 1. Okay, so how do you do that? Go step by step. AB is what? 2 and 5. BC is what? 4 and 3. Which is the common variable here? B. What is B representing in different equation? Let's say equation number 1 and 2, 5 and 4. How will you make them equal? You multiply this 4 there up in the equation number 1 and multiply 5 down in the equation number 2. How will it look like? It look like this. Multiply 4 in equation number 1 and multiply by 5 in equation number 2. See what you get. You get A's to B as 4 2s are 8, 4 5s are 20. You get B's to C as 5 4s are 3 and 5 3s are 15. Yeah, job done. You got B representing same numbers here. Yeah, that's why B was 4 in equation number 2 and B was 5 in equation number 1. So that 5 from equation number 1, you multiply the equation number 2 entirely, and 4 from equation number 2, we multiply in equation number 1 entirely, because that's a property of ratio, right? This is called scaling property. You scale it to make them represent the same values. Well, now we got what? A, B, C as what? A as 8, B as 20, yeah, B as 20. Both should have equal value. Otherwise, you can't write simply B's value as 20. Both should have 20. Then only you can write 20. A compare with B. So A is 8, B is 20. And B compare with C. And B is 20, C is 15. Yeah. Okay. Now let's take the next term, which is C and D. C is to D. We got C into D. C is to D as 2:1. No problem. Go with the thumb rule. C, which variable is same in both equations. So here you got C same. Okay. Now C here represents 15, and the next equation it represents 2. Bahut nainsafi hai. You can't have different values, right? So what do? You make them equal. How will you make them equal? You multiply the equation number 1 by 2 and by 2, because here the second let's name it as equation number 3 and 4, not to get confused. Huh? So in third equation C represent 15. So this 15 I will multiply in this fourth equation, and equation number 4 says C equal to 2. So C equal to 2 I multiply in the third equation. Yeah, see this, need to make them equal. So 15 multiply down, 2 multiply up. Okay, and multiply in all the terms. Right, you can't only multiply in 15, 2 you have to multiply in all the terms. That's the property of ratio. I'm repeating this again and again, don't make mistake here. So let's see what you get. A, B, C. Shall I write D also here? No, will you get confused? Okay, no problem, I'll do it in the next step. But when we keep doing this this kind of if we keep getting this kind of question in future, I will not write all the steps, I'll skip some steps. Okay, that's where you save time. Okay, and wherever you save time, whenever you get to save time, that's where you have shortcut. Yeah, what is shortcut? You save time. So multiply by 2. So A is 16, 8 2s are 16, B is 40, 20 2s are 40, and C is 15 2s are 30. Well, what do you have C and D here? C is 15 2s are 30 and D is 15 1s are 15. You got value of C, same here, correct? Now you can simply write A, B and C as and D as well. So A, when A is 16, how will we read it? How do we read this in ratio? When A is 16, then B is 40. When B is 40, then C is 30. When C is 30, then D is 15. That's how we read it. Okay. So A, B, C, D is this. Is that your answer? No. Question said find the ratio of A, C, D. A, C and D. So let's find the ratio of A, C, D. Let's write only A, C, D because question said find A, C, D. Write A, C, D, no problem. No problem at all. No problem at all. Only write A, C, D from here. So A is 16, C is here 30 and D is here 15. And you know, when you write this, match with the option. If you are not able to, if you match with the option, or you can also see, can we still deduct further? Can we deduct these values further? Deduct means can you cancel by some common number? You cannot. 16, 30, 15, there is no common number which can divide all of them. So this is the ratio. I hope you are getting scaling property. I got one more question for you. I want you to pause this video. I want you to pause this video here, right now, and look at the question. Try to solve by yourself. Use scaling property to compare, to make the same variable representing same values, same numbers. Okay. All right. So let's try this together and you check whether my answer is correct or not. Well, it says, this says B is to C, B is to A equal to 2 is to 3 and A is to C equal to 5 is to 7. You need to focus on the same variables. Here the same variable is A. Okay, what is the representing value, representing or respective numbers which A represent? I have with them. I have them with me. 5 is to 7. So here A is 3 and here A is the first term, so 5. You remember what you need to do? Yeah, equation number 1 and 2. This 5 you multiply from second equation to the first equation, and this 3 you multiply from first equation to the third equation, second equation, right? Okay, and I am going to write B, A, C all together. Shortcut, remove steps. 5 I multiply in the entire equation number 1. So 5 2s are 10. So B is 10. If B is 10, then A is 5 3s are 15. Do you see they are still in ratio 2:3? Yeah. So multiplying or dividing by common number does not change the ratio. Okay. And this 3 you multiply in equation number 2. So what do you get? When A is 3 5s are 15, which we already have, C is 3 7s are 21. Scaling property. Okay, I hope that's clear. So this is shortcut. I have, if you compare this solution with the first question of scaling property which we have solved, this solution will look little shorter. Shortcut. There we have explained in detail, we have discussed in detail, because you need to build the foundation well. Okay, now what do you need to find? A plus B by B plus C, right? Now for your convenience, I need to do a lot of things for your convenience. No problem, I'll still do it for your convenience, because I need to solve, I need to find this out. So let me have the value of ABC. So I will assume, I'll say let, and I will use what, which method? The assuming method. I will assume B equal to, so assuming method says what? If you got ratios equal to some numbers in ratios, so representing some variables, so I can take this B as a portion of B, which is 10, and then with a common multiple, let's say X. That's the assuming method. Go to lecture number 1 and see how did we use assuming method there. A we assume with A's portion 15 and a common multiple X. C same thing, 21X. Now let's substitute A, B and B, C here. So A is 15X, B is 10X, here B is 10X, and C is what? 21X. What do you get? Here you get 25X, and this is 31X. And then here X cancel. So at the end, the ratio you got, A plus B and B plus C, ratio you got is 25 by 31. So then you may ask me that sir, if you had to cancel, then why did you assume X? You never know whether X will get cancelled or not. If X will not get cancelled, then we will come to some different conclusion. So if it will happen in future ever, I will tell you what will be the conclusion then. Okay. Yeah. And when we keep practicing ratio, we will understand when will this assumption is going to make any difference, and when that assumption not going to make any difference. We'll see that. Okay. So as of now, that question is clear. Cool. Again, pause video, try to solve this question. So you got, the question said 1980 is divided amongst A, B and C, so that half of A, 1/3 of B and 1/6 of C are equal. Find B. Okay, let's see what do we do with, how can we solve this. So let's go with the given information. So half of A's part, all of them are equal. Okay, equal to 1/3 of B's part, equal to 1/6 of C's part. Okay, now I need ratio of ABC to get the value of B here, B's part here. So can I do it like ABC as 1 upon the number which is in multiplication here? Okay, 1 upon 2 is 2. For B, 1 upon the number which is in multiplication of B, 1 upon 3. And for C, it is 1 upon the number which is in multiplication of C. That's 1 by 6. Okay. Now, as I said, as I have told you earlier also, denominator will go into numerator, right? Absolutely right. So this will become 2 by 1, this is 3 by 1, and this is 1, this is 6 by 1. Okay. Great. So you got the ratio of ABC. Now question said total value of ABC put together is 1980, and we need to find out B's part. Can I use portion method here? Portion method here. Huh? Can I use portion method? What is the portion method? Let me take you to the portion method again. Units equal, yes. Partitions, yes. Portion method here. Find by given. Do that. Find by given. What do we need to find? B's part. What is B's ratio? 3. What is given to us? Total. What is total's ratio? 2 plus 3 plus 6. 11. Okay. So we got B by total. That's the ratio. And if I only want to find out the B's value, I will say this total is nothing but, the total is nothing but 1980. Yeah, total is nothing but 1980. So what is B's value here? B's value will be 3 by 11 into 1980, and see how easily we can divide 1980 by 11. 11 ones are 11. You have 8 here, so 11 8s are 88, and then we got 0 in gift. Okay, so B will get you this. B will be equal to 3 into 180 is 540. That's your answer. I hope your answer is matching with my answer, right? Yes. Great. So this is it in today's video. We have discussed scaling property. If you want to revise this again, go through that, because in next lecture we are going to pick up some random questions of ratio, and I am going to use these methods and a lot of shortcuts there. All right. So I will see you in the next lecture. Till then, stay happy, stay healthy. Bye bye.